Hello friends, in this session we are going to quickly see the topics that are important for logical reasoning. Definitely there will be questions on these topics like syllogisms. Now, what do you mean by syllogisms? If you have seen our previous videos, you must have realized that questions from syllogisms become really easy if you do sufficient practice rather than just go with the theory or some formula that you might read in the books. It is not a formula oriented topic. It is about self-understanding, how well you understand the syllogisms. So let me take a few examples for you. So as you know, syllogism is a form of deductive reasoning in which a conclusion is derived from two or more premises. The premises are actually a set of statements given in the question, and usually it is asked to find whether the one or more of the conclusions given are logical deductions from the statements or not. This type of questions can easily be solved by using Venn diagrams. So of course, we are going to use Venn diagrams to solve these type of questions. In simple words, syllogisms in the questions of syllogisms, a data is given in form of statements and what we can infer from it 100% of times. That means in every case, whatever we are inferring, whatever we are deducting, whatever logical conclusions we are forming, those should be 100% true in all the possible cases. Then only they are considered as logical deductions. Otherwise, they will not. For example, the implication of all, some not, no. So for example, the statement says all A's are B's. This is a statement. So what different things we can infer from it or we can deduct from it? All A's are B's may mean that all A's are B's. So this set is showing A and this set is showing B. So can I say all A's are B's from this set? Yes. If I show it like this, that all A's are B's, A and B, they are overlapping on each other. Can I say all A's are B's in this statement as well? Yes. But now, when we talk about having deductions, can I deduct some B's are A's from this? Yes, we can. From the first also we can infer this, and from second also we can infer this. Now, this conclusion is true from both of our possible drawings. These two are the possible outcome of this or possible diagrams for the given statements. And both of our possible diagram, they are correlating, or we can prove this true in both of our diagrams. So this will stand true in all the cases, and hence it is a clear and correct conclusion. Some B's are A's. But if I say all B's are A's, is this conclusion true in the first one? No. Is this conclusion true in the second one? Yes. So in second one, it might be yes, but in first one, it is no. So as I said, a conclusion only stands true if it is true in all the possible drawings. So if we are having the drawings like these two, in case of all A's are B's, but in this drawing, the drawing number 1, if this conclusion does not stand, that means it is a wrong conclusion. It is not even a 50% right conclusion. It is a wrong conclusion. A conclusion has to stand true in all the possible outcomes. So how to have the thought process for these type of questions? Because every time, if you don't do sufficient practice and you can't get your thought process aligned with what the requirement is, then it really becomes difficult for some student to solve this question. So my suggestion to them is have a specific kind of thought process. Like I gave you the example. There was a serial named Khichdi. It used to run on Star Plus, I guess. There was a character named Praful in that serial. He had one specific kind of habit. Whatever comes or whatever statement is made, he used to say it is not necessary. Aisa zaruri nahi hai. And then he used to counter it. It's some obviously stupid arguments, but the nature you have to adapt that. That aisa zaruri nahi hai. It is not necessary. And then only Having that into mind, you can then counter it. So for example, they give a statement all A's are B's and they say all B's are A's. So first thought process into your mind should be, I need to disprove it. ऐसा जरूरी नहीं है. Can I disprove it now? Yes, I can show them this diagram, that in this diagram all A's are B's. Yes, true. Statement is true. I'm not avoiding anything. But this conclusion is not true in this diagram. So you don't have to draw all the possible cases if you have this thought process in your mind that, as I said, ऐसा जरूरी नहीं. Right? Let's see another example. In this here, statement is some A's are B's. So some A's are B's I can draw with several different examples. I can say some A's are B's like this. Can I say some A's? There are some A's in this A circle. They are also B's. Yes. Can I draw it like this? Some A's are B's. This is A, this is B. Can I say some A's are B's? Now you might say, no, it means all A's are B's. Yes, of course. It means all A's are B's as well. But does it mean that some A's are B's? It is not showing in this diagram. No, it is also showing some A's are B's. See, there are these some A's which come under A circle. They are also in B circle. So some A's are B's. Fine. We are not talking what the other implications are. We are just thinking about, am I showing the given statement or not? So yes, I am showing some A's are B's. If I draw it like this, some A's are B's. Am I showing some A's are B's? Again, yes. There are these some A's which are in A circle. They are also in B circle. So some A's are B's. Yes, fine. And if I draw again overlapping diagram like this, some A's are B's. So A and B both on each other. Can I say now some A's are B's? Yes, again. There are some A's in the A circle. They are in B circle as well. So there are all four possible diagrams for this statement. So if I say the conclusion, can you draw this conclusion like some B's are A's? So this conclusion will be true in the first one. Yes, some B's are A's. Some B's are A's. Yes, true in second. Some B's are A's. There are some B's which are A's. Yes, true in third. And some B's are A's. Yes, true in fourth as well. So because this conclusion is true in all the four outcomes, that's why it is a true conclusion. But if I say all B's are A's, so obviously it won't be even correct in the first one. It won't be correct in the second one. It will be correct in third one and fourth one. But as I said, even you can disprove it one time, it will not be a correct statement. So it is not going to be a correct interpretation or implication. If I say some B's are not A's, negative statement, negative conclusion, some B's are not A's. Is it true in first one? Yes, there are some B's which are not A's. So first one, it is true. Some B's are not A's. Can I say here? Yes, there are some B's which are not A's. True in the second one as well. In third case, are there any B which are not A? No. Entire B is inside A. So we can't have some B's, those are not A's. And in the fourth also we can't have. So that is also going to be a wrong conclusion. But if I say all B's are A's is a possibility. If this is a conclusion, is a possibility. Now, when they use the word like possibility, then you have to go in suppose with them. That means in support of them. You just have to draw the diagram or consider a diagram which will prove this right. At least one diagram if you have that all B's are A's. So you can show them this or this diagram. And yes, all B's are A's is a possibility because one of the case is having all B's are A's. So in that case, this conclusion will stand true. If this word was not used, then it would be a wrong conclusion. But if this word is used, possibility or all B's can be A's, words like this if are used, then you have to go in support of them. If the words are not used, then you have to think, like I said, like that character, ऐसा जरूरी नहीं है, and then you have to go in oppose of them. Let's have some practice. Consider this statement: all men are brothers, all brothers are fathers. So you can draw the diagram like all men are brothers. This is men, this is brothers. All brothers are fathers. So all brothers should come inside fathers. Conclusion is some fathers are men. So yes, obviously, there are some fathers, they are going to be in father circle and they are going to be man circle as well. So first conclusion is definitely true. This conclusion is definitely true. There is only one conclusion, so we'll mark yes, it is a true conclusion. Second, no movie stars are comedians, all producers are movie stars. So we'll draw no movie star are comedian. That means there can't be any intersection between movie star and comedian. All producers are movie star. All the producer will lie inside the movie star. Now they are saying conclusion, some comedians are not producers. So yes, definitely true. Because if producers can't intersect, if movie star can't intersect with comedians, the producers being inside the movie stars, they of course can't intersect with the comedians. That means some comedians are there which are not going to be producer. So this is a true conclusion. Don't look for the option. They are not for these type of questions. There is only one conclusion. Third, all bikes are transport, some bikes are home trainers. All bikes are transports. And some bikes are home trainers. So some bikes are home trainers. You are going to draw it like this. There has to be some intersection between bikes and home trainers. Now, they are saying no transports are home trainers. They are saying there can't be any intersection between transports and home trainers. Is it possible? No. Because if the bike like entirely in the transports and some bikes also intersect with HT, that means the intersection between transports and home trainers is definitely there. So that means it is not a true conclusion. Fourth, all streets are routes of transportation. All streets are routes of transportations. No streets are racing track. So that means there is no intersection between routes, streets and racing tracks. While drawing this, you must understand that these two may intersect. If needed to prove, these two may intersect. Only streets won't intersect with racing track. Now the conclusion is some racing tracks are not routes of transportation. So yes, definitely. Because these many racing tracks, they can't intersect with sorry, these are the streets. Some racing tracks are not routes of transportation. So no, this is not a true conclusion because this entirely can go inside this as well. You can just draw it like this. All streets are routes of transportations. This is routes of transportations. And then no streets are racing tracks. So streets are not going to intersect with racing tracks. And in this diagram, some racing tracks are not routes of transportation. It is a wrong conclusion as entirely racing tracks can come inside the routes of transportation. So it will be a wrong conclusion. Okay, let's try these type of questions now. All A's are B's, all B's are C's. All A's are B's, all B's are C's. A, B, C. Can we say some A's are B's? Yes, definitely we'll have to say this. Some A's are C's? Yes, we can say this. We'll have to say this. So both conclusions are true. Both conclusions follow. Let's see one more. All P's are Q's. No Q is R. All Qs are Ps. Is it true? No. You can see it is not at all necessary that all Qs are P. Some R are P. No. Because if there is no intersection between R and Q, you can't say R will intersect with P. So both are wrong conclusions. Answer will be D. No X is Y. There won't be any intersection between X and Y. All Y's are Z's. So entire Y will come inside the Z. Now, no X is Z. This Z can intersect with X as well, because there won't be any intersection between X and Y only. Z can intersect with X. So no X is Z is a wrong conclusion. Some X can be Z, they can intersect. Some Z are Y, definitely. So second is a true conclusion, first is a wrong conclusion. So answer will be only one of the conclusion follows. Some C are D. Some C are D. All D are E. So entire D should come inside the E. Some C's are E's. Yes, definitely. Some C's will be there which will come inside the E's as well. Some D are C, definitely. If some C are D, then some D's are C will be true. Both the conclusions are true. Option number C. All mangoes are apple. No apple is banana. Apple won't intersect with banana. No mango is banana. Yes, definitely true. Because if apple is not going to intersect with banana, mango being inside definitely can't intersect with banana. Some apples are not mango. It is not true, because you can draw the diagram like this as well. All mangoes are apple. You can draw it like this as well, like overlapping with each other. All mangoes are apples. And then no apple is banana. But then in this diagram, you cannot say that some apples are not mango. All apple can be mangoes as well. So second is a wrong conclusion. Still mark, only one of the conclusion follows. Some moons are planets. Some planets are solars. Some solars are planets. That's definitely true. And some planets are moons, also definitely true. So both conclusions follow. No boys are girls. So between boys and girls, there won't be any intersection. Some girls are intelligent. Now, drawing this, you have to realize that this boys and intelligent, they can have intersection. The entire boys can go inside the intersection, intelligent as well. So some boys are not girls. It is a true conclusion. Because if all boys are not girls, then some boys definitely won't be girls. Some boys are not intelligent. It is not true. Because as I just said, this entire boys can go inside the intelligent as well. So all boys intelligent is also possibility. That means this is a wrong conclusion. Some books are stacks. Some stacks are queues. No queue is tree. No books are queues. It is not necessary, because they can intersect as well. Books and queues can intersect. So not necessary. No stacks are trees. Stacks and trees can intersect. Only queue and tree won't intersect. So that's also wrong. Some stacks are not tree. That is true, because these many stacks which are intersecting with queue, they cannot be tree. So this is a true conclusion. Some books are trees. It is not necessary. As you can see in this diagram, they are not intersecting. So only one is correct, that is third. So answer will be only 3 follows. No doctor or patient. Doctor and patient won't have any intersection. All patients are females. All females are nurses. Some females are not doctor. So some females are not doctor is a true conclusion because these many female, they cannot intersect with doctor. So some females are not doctor. Some doctors are not female. That is also true. Sorry, some doctors are not female. It will be wrong because the doctor can entirely go inside the female like this. So it will be a wrong conclusion. Some nurses are patient. Yes, that is definitely true. Some nurses are patient. All nurses are patient will be wrong. So only 1 and 3, they are going to follow. Only 1 and 3. All trees are pencil. All pencils are jungle. All books are trees. Some trees are jungle. Yes. No trees are jungle. No. All books are jungles. Yes. And some jungles are books. Yes. So 1, 3 and 4. All these three follow. Option number C. Let's see some RBI grade B questions. Some lipsticks are gloss. Some gloss are not lip balms. So when we say some gloss are not lip balms, that means you have to draw the diagram like lip balms here. But you can't have entire glosses into the lip balm. Entire can't go. Some intersection is possible, but entire gloss cannot go inside the lip. This is how you show it. All lip balms are lip pencils. Conclusion. Some lip pencils being gloss is a possibility. Yes, they can intersect with each other. So possibility, yes. All lip balms being lipstick is possibility. All lip balm going inside the lipstick is yes, possibility. You can have all lip balms here inside the lipstick. Some lip pencils being lip balm is possibility. Some lip pencil being lip balm is possibility. It is in fact true. So answer will be all three, means you can say none of this. Some poles are not stops. So again, same thing. You can't have entire poles inside the stops. Some poles are not stops. Some signals are not poles. So all signals cannot go inside the poles. Some stops are not signals. So the stops cannot go entirely into the signal. Some poles are definitely not signal. Yes, as we know, some poles are not. Some poles are definitely not signal. So no, that is will be a long conclusion. The entire signal cannot go inside the poles, but entire poles can go inside the signals. Some signals are not poles. Yeah, that is true. Some signals are not poles already given. All poles being signal is possibility. Yes, that is also true. So here also the answer will be none of this. Some horror can be drama. So this question is reverse kind. In this question, the statements are as an option and conclusions you have to derive from the given statements. So if the first set we select, no drama is horror, no drama is action. So can we say some horror can be drama? No, because if no drama is horror, some horror cannot be. So first is wrong. No horror is action. All comedy is action. All drama is horror. So can we say some horror can be drama? Yes. Some comedy is not action. No, not necessary to. All comedy can be action as well. All horror is comedy. All drama is comedy. No drama is action. Drama and action, they can't intersect with each other. Some horror can be drama. Yes, they can intersect with each other. Some comedy is not action. Yes, definitely. This some comedy, it is not action. So this will be a correct option. Now we'll go by options again. Some penguin is dolphin. No shark is penguin. Some crocodile is dolphin. Some dolphin is not penguin. Is it necessarily true? No. Some crocodile can be. So first is wrong. See, if the conclusion has a negative statement into it, the statement has to have some negative into it. So all shake is crocodile, all penguin, some penguin. That is also not there because there is no negative statement. All shark is dolphin, all dolphin is crocodile, no crocodile is penguin. We'll go for this then. All shark is dolphin. All dolphin is crocodile. No crocodile is penguin. First conclusion, some dolphin is not penguin. So yes, there are some dolphin which cannot be penguin because penguin can't intersect with the crocodile even. Some crocodile can be penguin. No. If it's still no crocodile is penguin, some crocodile can be penguin is wrong. D, no shark is penguin. Sorry. No shark is penguin. Some dolphin is shark. Some dolphin, no dolphin is crocodile. First, some dolphin is not penguin. Yes, these many dolphins, they are not penguin. Some crocodile can be penguin. Yes, the crocodile can intersect with penguin. So both the conclusions will be true for option number D as the set of statements. Some Shizuka is Doraemon. Sorry, we'll go with the again options as it is again a reverse question. Some Shizuka is Sunio. No Sunio is Doraemon. Some Nobita is Doraemon. First, some Shizuka is Doraemon. No. Second option, all Nobita is Shizuka. All Doraemon is Nobita. No Doraemon is Sunio. First, some Shizuka is Doraemon. Yes, definitely. Some Nobita are not Suni. So yes, these many Nobita will be there which cannot be Suni. So both will be true for this option. Option number B. Let's see one more. Now multiple statements are also can be the option. So we'll go with the option. Only statement 4. So let's go for the statement 4 first. Only few wires are threads. So only few wires are threads means the entire wire cannot go inside the threads. Only a few wires are pipes. Only a few wires are pipes means again same thing. The entire wire cannot go inside the pipes. Some threads are sticks. Conclusion. Some wires are not threads. Definitely. Because as I said, entire wires can't go inside. All wire being pipe is possibility. Same thing, no, not possibility. So 4 is not true. So if 4 is not true, this also cannot be true. Now we have to go for 1. Only few wires are thread. So entire wires can't go inside the thread. All threads are pipes. Some pipes are not sticks. That means entire pipe can't go inside the sticks. Some pipes are not sticks. First conclusion. Some wires are not threads. Yes, that is a true because entire wire can't go inside the threads. All wire being pipe is possibility. All wire being pipe is possibility. Yes, wire entirely can go inside the pipe. So that is a true. That means 1 is a true. But we'll have to go for third as well for this option. Third, only a few wires are thread. So wires can't go entirely inside the thread. Only a few wires are pipes. Same thing, wires can't go inside the pipe. So all wire being pipe is a possibility that will again void in the fourth and third. So answer will be only option number 1. Only statement 1 will be true. Let's go with the option again. Fourth is there. So let's go directly for fourth. Some mouse are not dogs. So entire mouse cannot go inside the dogs because some mouse are not dogs. Some horse are cat. And it says some horse is mouse. So we'll draw that part first. Some horse is mouse and some horse are cat. Conclusion. Some cat are not mouse. No, it is not true. The cat entirely can go inside the mouse. So that is a wrong. So fourth is a wrong. That means this will also be wrong. Let's go for the first. Some horse is mouse. Some mouse are not dogs. So entire mouse cannot go inside the dogs. All horse are cat. Conclusion number 1. Some cats are not mouse. No, not necessarily true. All cats can go inside the mouse as well. Only 2 will go for the option number 2 then. That's the only option left. That means that has to be the answer. But still we'll go for it. Only a few horses mouse. So entire horse cannot go inside the mouse. Some mouse are not dogs. So entire mouse cannot go inside the dogs. All horse are cats. First conclusion, some cats are not mouse. So yes, there will be some cats which will stay outside the mouse, which are horses. First is the correct conclusion. All mouse can be horse. Yes, that is true. Horse can't inside the mouse entirely, but mouse can enter entirely inside the horse. So that is also correct conclusion. So both are correct for statement number 2. That has to be the answer. The next topic we'll discuss is inequality. Now these are again very easy type of questions. Let's see some questions from inequalities. So you know the pattern of these questions. Some statements will be given in form of inequalities, and then you have to see which conclusion stands true. In here, we have to compare D and R. So there are two different chains. We have to see the common factor between these two, that is O. So between D and O, we know D will be less than O, as there is this sign between D and O. So D will be less than O. And between O and R will be greater than O. So R will definitely be greater than D. Yes. Between Y and K, Y is equal to O and K is greater than O. So we can say Y is equal to O and K is greater than O. So K will be greater than Y. So that is a wrong conclusion. So only conclusion 1 will be a true conclusion. Let's see next one. We have to compare between P and S. Now between these two trends, the common element here is N. As you can say, N is greater than or equal to P, and between and S will be greater than N. So S will be definitely greater than P. So it is not a correct. S has to be greater than P. T and Y. So between T and N is a common factor between these two. So between T and N, there is a contradiction. That means this relation cannot be established between T and N. So whatever relation N will have with Y, it doesn't matter because T and N themselves have the contradiction. So that's why this relation also can't be formed. So we'll say neither relation 1 nor 2 is true. U and E. U and E. So there is L is common between these two. So you know U is greater than L. And between L and E, you know L will be greater than E. So U will be definitely greater than E. It's a correct statement. T and Y. So Y is here and T is here. So the common factor we'll have to see here is T is equal to L. Now L is greater than P. And then between P and Y will be greater than P. So there is a contradiction between T and Y. So we say no relations can be formed. So this is a wrong conclusion. So only conclusion 1 will be true. Let's see the next one. S and B. So between these two trains, the common factor here is H. So you know H will be greater than B. H is greater than B. And between H and S, there is a contradiction. So we can't have this relation. Y and K. Between H and K, H is less than K. And between H and Y, Y will be less than H. So K will be greater than Y. It is a true conclusion. So only conclusion 2 is true, will be the correct one. Between this train and this train and this train, the T is common between these two. And R is common between these two. So now P is less than R and R is less than S. P is less than R is less than S. So P is less than R is a correct conclusion. So that means this is not true. Only one is correct. Only conclusion 1 is true. Because P and S can have only one relation between them. Either P will be less than N or greater than equal to. But P already you know as less than N, S. So that is going to be a true conclusion. A and D. A is less than D. It's a true conclusion. G and B. G and B. So there is F common here and there is C common here. So we'll say between G and B, F is greater than G. Or between F and C, C is greater than F. And between C and B, C is equal to B. So B will be definitely greater than G. That is a true conclusion. So both the conclusions are true. K and O. K is here. L is here. There is M common between these two. So we can say K is less than L. L is less than M. And M is less than O. So O will be definitely greater than K. It's a correct statement. And between M and K, M will be also greater than K. That is also correct statement. So both conclusions are true. Option number C. Z is greater than C. So Z and C here. Definitely Z will be greater than C. X and W. There is X here and there is W here. So W will be greater than X. That is a correct. So both are true. Now Q and M we have to compare. M is here. Common factor is L. L is greater than equal to M. As compared to L, Q will be greater than equal to. Q will be greater than equal to L. So Q will be greater than equal to M as well. That means Q will be either greater or equal to M. So 100% this is also not true, 100% this is also not true. But either of them has to be there. So we'll mark the option as either one or two is true. P is greater than Q. Q is less than equal to R. R is greater than S and S is less than T. Now they are asking about S and Q. Equation to not possible. S is equal to Q not possible. T is greater than equal to P. Again, there is a contradiction between T and P. like this or this. So this conclusion also does not follow. So we mark that both conclusions, neither conclusion is true. K is greater than I. K is here, R is common. R is less than K. Between R and I, R will be greater than I as well. So there is a contradiction between K and I. This is the wrong conclusion. Between I and Z, there is R common here. There is a N common between the first one and the last. So we can say I is equal to N. N is less than Z. So I will also less than Z. That is a correct conclusion. So answer will be option number 2 is true. Only conclusion 2 is true. Okay, we're done with this one. N and K. N is here, K is here. There is I common between these two. There is G common between these two. So K is equal to G. I is greater than G and N is greater than I. So N is greater than K. It's a correct conclusion. C and T. Between these two, the common is G. C will be greater than equal to G. G is greater than equal to J. Or G is equal to K. And K is less than T. So there is a contradiction between C and T. So we say no, this is not the correct relation. M and J. J is greater than M. J is less than equal to K. K is equal to G. G is less than I. And between I and M, I is greater than equal to M. So there is again a contradiction between J and M. So that is also not a true conclusion. So only one will follow. We have to form relation between P and H. P is here. The common factor is B. The common factor is X and then H. So P is less than equal to B. B is less than X. X is greater than equal to H. So here also there is a contradiction. So this relation is not true. So this is also not true. R and X. R is greater than X. R is greater than Y. Y is less than equal to X. So there is also contradiction. So this also does not follow. So answer will be none of the conclusion follows. G and C. G is less than D And between D and C, there is a contradiction. So no, it is not going to follow. Equation obviously doesn't follow because you can't say that H is equal to A. H is greater than C and C is less than A, you can say, but both are equal, not possible, or not 100% true. So both conclusions won't follow, neither one nor two. Between Y and Z, we have to compare. Y is greater than equal to X, and X is greater than equal to Z. So Y will be greater than equal to Z. So it will be either greater or equal. So answer you mark is either one or two. Now this is a question from RBI Grade B 2021. DR. We have to compare between G and R. So we can say first D is greater than R. Now R and L, there is a contradiction. G is greater than L. Between R and L, there is a contradiction. So this relation can't be formed. T is greater than W. T is greater than G. G is greater than L. So T will be greater than L. L is greater than equal to W. So T will be greater than W. Yes, it's a true conclusion. So if 2 is true, you are going to mark either option number B. But of course, there is none of these as well. So let's go for 3 as well. W is less than equal to D. So W is less than equal to R and R is less than D. So W should be less than D, not less than equal to. That is also wrong conclusion. So only 2 is true conclusion. We have to compare between G and R. G is greater than L. And between L and R, there is contradiction. So no. T is greater than W. So T is greater than G. G is greater than L. L is greater than equal to W. So that is a true conclusion. So only 2 is true is correct. We have to compare between C and F. C is greater than equal to D, and then D and F, there is a contradiction. So there is no relation like this. E and A. E is equal to D, or E is less than equal to C, and C is less than A. So E will be less than A as well. That is a wrong conclusion. Third, G is less than B. Between G and B, the common factor is D from here and then C from here. So we can say G is less than equal to D, D is less than equal to C, and C is less than A. And C is less than equal to B. So relation between G and B is G is less than equal to B. So that is also wrong conclusion. Okay, we have to compare between D and R. T and P. D is equal to P. P is less than equal to M, and M is less than equal to R. So T will be less than equal to R. So T will be either less or equal to R. So either one or two will be the answer.